In the very beginning, there was almost nothing. A vast, silent darkness. Then, a sudden, brilliant flash of light. From this incredible moment, our universe was born. In that first searing heat, the very first atoms began to form. They were the simplest things imaginable, the building blocks of everything that would ever exist. This first element, born from the fire of creation, was hydrogen. It is the oldest thing in all of existence. It is the most abundant thing in all of existence. It is the stuff of stars. It is the fuel of galaxies. In a strange and wonderful way, it holds a key to our own future, a quiet promise of a cleaner world. If you find this video interesting, please consider liking and subscribing to my channel. Now let's get started. This journey we are about to take is a journey into the heart of that very first element. We will travel from the unimaginable scale of the cosmos right down to the tiny, invisible world of the atom itself. It connects the birth of the stars to the car you might one day drive. We will explore what hydrogen is. We will explore where it came from. We will explore how its unique nature makes it so useful. It is a story of discovery and human ingenuity, and of our quest to find better ways to power our lives. It is a quiet tale, but one of great importance for us all. This invisible gas, the lightest of all things, can power a rocket into space. It can also help grow the food on our plates. It is a substance of curious contradictions. It is simple, yet can be used in complex ways. It is gentle enough to be part of the water we drink, yet it can burn with a fierce, almost invisible flame. Understanding hydrogen is like learning a secret language of the universe. It is a story unfolding for billions of years, and we are now writing its next, most crucial chapter. So, let us begin. Let us look closely at this fundamental substance. We will strip away the complexity and see it for what it is, a single proton and a single electron, a simple beginning for a universe of endless wonder. This simple atom holds the power of the sun and the hope for a sustainable world on Earth, from the very beginning of time itself, to the fuel tank in your car. The story of hydrogen is, in many ways, the story of everything. It is a tale worth knowing, affecting us all, whether we are aware of it or not. If you were to look at the grand map of all the elements, the blueprint for everything in the universe, you would find hydrogen right at the very beginning. This map is called the periodic table. Hydrogen sits in the top left corner, all by itself. It is given the number 1. This is because it is the simplest and lightest element of all. There is nothing more basic. Every other element is built up from more complex parts. Oxygen, we breathe iron in our blood. Hydrogen, however, is the fundamental starting point, the first and most humble brick in the cosmic wall. This beautiful simplicity is what makes hydrogen so unique and so important in the grand scheme of things. Its unique position on the periodic table makes it a bit of a loner. Sometimes it behaves like the reactive metals in the first column, and at other times it acts more like the gases in another group. It does not quite fit in anywhere perfectly. This is because it is so keen to share or give away its single electron. A hydrogen atom on its own is not very stable. It is always looking to connect with other atoms. That is the secret to its power. It is what allows it to form water, to create energy, and to be part of nearly every living thing on our planet. This fundamental drive to connect is why you will almost never find a single hydrogen atom floating around on its own here on Earth. Instead, they pair up. 2 hydrogen atoms will share their electrons, forming a stable molecule we call H2. This is the form we find hydrogen in when it is a gas. To find the true origin of hydrogen, we must cast our minds back to the very beginning of time. In the moments after the initial spark of existence, The universe was an incredibly hot, dense soup of tiny particles. As this cosmic soup expanded and cooled, the very first atoms began to take shape, and the first, simplest atom to form was hydrogen. The universe became filled with vast, dark clouds of this primordial hydrogen gas. It is no exaggeration to say that hydrogen is as old as the universe itself. It is the original matter from which everything else was eventually built. Look up at the night sky, at the countless stars that glitter in the darkness. Every single one of them is a testament to the power of hydrogen. Stars, including our own sun, are gigantic balls of hydrogen gas, held together by their own immense gravity. Deep within the core of a star, the pressure and temperature are so extreme that hydrogen atoms are forced together in a process called nuclear fusion. They fuse to create the next element, helium, and in doing so, they release a tremendous amount of energy. This energy is the light and heat that pours out from the star, traveling across the vastness of space. Here on Earth, hydrogen is everywhere, but it is rarely found on its own as a gas. It is so light that any free hydrogen in our atmosphere would simply float away into space. Instead, it is locked up in compounds with other elements. The most common of these, by far, is water. Every single molecule of water, written as H2O, contains two atoms of hydrogen bonded to one atom of oxygen. The great oceans, the rivers, the clouds, and the ice caps are all gigantic reservoirs of hydrogen, bound tightly into the form of water, waiting to be released. Beyond water, hydrogen is also a key ingredient in almost all living things. It is found in the foods we eat, like sugars, fats, and in the very fabric of our bodies, in our DNA and proteins. It is also found trapped underground in fossil fuels, like natural gas and oil, which are the remains of ancient life. So, while we may not see it or breathe it as a pure gas, hydrogen is an invisible but essential part of our world. From the heart of a distant star to the water in a glass, its presence is constant and fundamental to existence as we know it. For centuries, people had noticed a strange and flammable air that was sometimes created during experiments. When certain acids were mixed with metals, bubbles of a mysterious gas would appear. Alchemists, early scientists in the 1600s like Robert Boyle, observed this phenomenon. They knew they had created something unusual, a gas that would burn with a pop if a flame was brought near. They called it flammable air. But they did not yet understand what it was. They had captured a ghost, a spirit in the air, but they did not know its true identity or its fundamental nature. It was a puzzle waiting to be solved. The credit for truly identifying this gas goes to Henry Cavendish. In 1766, through meticulous experiments, he showed this flammable air was a distinct substance. He carefully studied its properties, noting how light it was. Most importantly, he performed a crucial experiment. He burned the gas in the presence of air, and the only thing left behind was pure, clean water. He had discovered the elemental makeup of water itself. It was not Cavendish who named it. That task fell to Antoine Lavoisier. Lavoisier repeated the experiments and confirmed the findings. Realizing this was key to water, he proposed a name. He combined two Greek words, hydro, meaning water, genes, meaning creator or former. The element became known as hydrogen, the water former. The name captured that this gas was the building block of the liquid covering our planet. The discovery overturned the idea that water was a basic element. Under the normal conditions we experience every day, hydrogen exists as a colorless, odorless gas. You cannot see it. You cannot smell it. You cannot taste it. One of its most defining features is its incredible lightness. It is the least dense of all substances. If you were to fill a balloon with hydrogen gas, it would shoot upwards far more quickly than a balloon filled with helium. This is why it was used in the very first airships, though its other main property made this a very risky business. This extreme lack of weight is a direct result of its simple atomic structure, having only a single proton at its core. The other defining characteristic of hydrogen is its flammability. It is highly combustible. When hydrogen gas mixes with oxygen from the air, it only needs a small spark to ignite, often with a distinctive pop sound if it is in a small quantity. It burns with a pale blue flame that is almost invisible in daylight, which is one of the challenges in handling it safely. This powerful reaction, the one discovered by Cavendish, releases a great deal of energy and produces only pure water vapor as a byproduct. This clean-burning nature is precisely what makes it so attractive as a potential fuel for the future. This simple element is incredibly sociable, always looking to form bonds with other atoms. Its desire to share its single electron makes it highly reactive. It can combine with a vast range of other elements to form an astonishing number of different compounds. We have already spoken of its bond with oxygen to make water, H2O. But it also combines with carbon to form the hydrocarbons that make up natural gas, CH4, and petrol. It joins with nitrogen to create ammonia, NH3, a vital component of fertilizers. Because it is a gas at room temperature, hydrogen must be stored carefully if we want to use it, for example, as a fuel. To get a useful amount into a container like a fuel tank, it must be compressed to very high pressures. This squeezes the gas molecules much closer together. Alternatively, it can be cooled down to an extremely low temperature, -253 degrees Celsius. At this frigid temperature, it turns into a liquid. Both methods require strong, specialized tanks and careful handling, but they allow this incredibly light gas to be stored and transported for use in everything from cars to rockets. Just like members of a human family might have slight differences, the hydrogen atom also has a small family of its own. These different versions of hydrogen are called isotopes. They are all hydrogen because they all have just one proton in their nucleus. That is the rule that defines the element. However, isotopes differ in the number of other uncharged particles in their nucleus, which are called neutrons. Most of the hydrogen in the universe has no neutrons at all. It is just one proton and one electron. This most common form is called protium, or simply hydrogen-1. The first sibling in the hydrogen family is called deuterium. A deuterium atom is still hydrogen. It has one proton and one electron, but its nucleus also contains one neutron. This extra neutron makes the deuterium atom about twice as heavy as a regular protium atom. Because of this, it is sometimes referred to as heavy hydrogen. Deuterium is not very common, making up only a tiny fraction of all the hydrogen on Earth. It is found naturally in water, where a very small number of water molecules are formed from deuterium instead of protium. This heavy water has special uses in nuclear reactors and scientific research. The third and final member of this elemental family is called tritium. As you might guess, a tritium atom's nucleus contains one proton and two neutrons, making it the heaviest of the three isotopes. Unlike protium and deuterium, which are stable, tritium is radioactive. This means that its nucleus is unstable and it slowly decays over time, releasing a small amount of radiation. Tritium is extremely rare in nature and is mostly produced artificially in nuclear reactors. It has some specialized uses, such as in self-powered lighting for things like emergency exit signs and watch faces, where its gentle radioactive glow can be harnessed. For most of hydrogen's everyday uses, these isotopes do not make a huge difference. When we talk about hydrogen fuel, or making ammonia, we are almost always talking about the most common form, protium. However, these heavier siblings, deuterium and tritium are incredibly important in the world of nuclear science. They are the key fuels being explored for future nuclear fusion power plants. While we often hear about hydrogen as a fuel of the future, it is already a quiet, unseen workhorse in our modern world. It plays a crucial, behind-the-scenes role in many industrial processes. One of its biggest jobs is in the production of ammonia. Hydrogen gas is combined with nitrogen from the air under high pressure and temperature to create ammonia. That ammonia is used to make agricultural fertilizers. Fertilizers are essential for growing enough food to feed the world. Without industrial hydrogen, farms would be far less productive. Another major use is in petroleum refining. Crude oil from the ground is a thick, complex mixture. To make useful products, it must be processed. Petrol, diesel, jet fuel hydrogen enables hydrocracking, breaking heavy oil molecules into lighter ones. Hydrogen also removes impurities like sulfur. Hydrotreating yields cleaner burning fuels. Cleaner fuels help reduce air pollution and acid rain. Hydrogen also plays a role in spaceflight. Liquid hydrogen is a premier rocket fuel. Combined with an oxidizer like liquid oxygen, it forms a powerful, efficient propellant. Their reaction delivers the thrust to lift rockets into space. The space shuttle's external tank held liquid hydrogen and liquid oxygen. Liquid hydrogen remains preferred for many upper-stage rockets. Beyond that, hydrogen is vital in other industries. In food production, it hydrogenates vegetable oils into margarine. In electronics, ultra-pure hydrogen creates controlled atmospheres for silicon chips. In metalworking, it is used for welding and for cutting, and to keep metals from exposure to oxygen during heat treatment. Hydrogen is a versatile, hidden partner in our technological society. Since hydrogen doesn't exist as a free gas on our planet, we have to make it. We have to unlock it from the compounds where it is trapped, like water or natural gas. The most common method used today, by far, is a process called steam methane reforming. In this industrial process, natural gas, which is mostly methane, CH4, is heated to very high temperatures with steam. This chemical reaction breaks apart the methane and water molecules, rearranging them to produce hydrogen gas, H2, and, unfortunately, carbon dioxide, CO2. This is a very efficient way to make hydrogen, but it creates a significant carbon footprint. Because this method relies on a fossil fuel, natural gas, and releases carbon dioxide, the hydrogen it produces is often given a color code. It is called gray hydrogen. The vast majority of the hydrogen used in the world today for things like making fertilizer and refining oil is gray hydrogen. It is a useful industrial gas, but its production contributes to the greenhouse gases that are warming our planet. A variation of this process that captures and stores the carbon dioxide byproduct is sometimes called blue hydrogen, which is a step towards being cleaner. But the most hopeful method is something else entirely. There is a much cleaner way to produce hydrogen, a method that mirrors the experiment that first revealed its nature. This process is called electrolysis. It involves passing an electric current through water, H2O. The electricity provides the energy needed to split the water molecules into their two constituent elements, hydrogen and oxygen. The hydrogen gas bubbles up at one electrode, and oxygen gas bubbles up at the other. If the electricity used to power this process comes from a renewable source, like wind turbines or solar panels, then the entire process is free of carbon emissions. This is the dream of the clean energy future. Hydrogen produced in this way is called green hydrogen. It produces no greenhouse gases during its creation, and when it is used as a fuel, it produces only water. It offers a way to store the intermittent energy from renewables. When the sun is shining or the wind is blowing strongly, the excess electricity can be used to make green hydrogen. This hydrogen can then be stored and used later, perhaps to power a bus, generate electricity on a calm night, or heat a home, completing a perfect clean energy cycle. We have journeyed from the dawn of the universe to the heart of modern industry, all on the trail of a single, simple element. We have seen how hydrogen, born in the initial creation, became the fuel of the stars. We have learned how it was discovered as a flammable air on Earth and how it is now locked away in our oceans and in living things. It is an element of profound duality, the simplest atom yet capable of immense power, a key component of water, yet it burns with a fierce flame. Its story is the story of matter itself, a continuous thread running through the fabric of the cosmos. Today, hydrogen is an industrial workhorse, toiling quietly behind the scenes to help feed us and fuel our traditional vehicles. But we stand at a crossroads. The grey hydrogen we have relied upon, made from fossil fuels, is part of the climate problem we must now solve. The challenge ahead is to transition from this old way to a new one. The path forward involves harnessing clean electricity from the sun and wind to split water, creating green hydrogen. This is not a simple task. It will require great investment, innovation, and a collective will to change how we power our world. The promise of green hydrogen is immense. Imagine a world where cars, buses, ships are powered by fuel cells that take in hydrogen and emit only water vapor, their engines running almost silently. Imagine steel mills and chemical plants powered by clean burning hydrogen instead of coal or natural gas, drastically cutting industrial emissions. Imagine a system where excess energy from a windy day can be stored as hydrogen and used to keep the lights on through a calm week. This is not a fantasy. It is a future that is technically within our grasp, a future built upon the planet's most abundant element. The journey of hydrogen is far from over. In fact, the most exciting chapter is just beginning. From its cosmic birth to its potential role in fueling our planet, this humble element has a remarkable story to tell. It reminds us that sometimes the simplest things hold the most profound solutions. Thank you for watching. If you liked this video, please like and subscribe to my channel and leave a comment. Take care. I'll see you in the next one.